So what is a mineral? A mineral is a naturally formed solid substance with a crystal structure. Now, minerals have many uses. Many things, including your house, your walls in your house, the concrete in your house, even the paint in your house are made from minerals. Many technologies are made of metals that require minerals. Jewelry requires minerals, and even some food products have minerals. Basically, anything that isn't grown has to have come from mining and minerals. Now, what do all minerals have in common? To be considered a mineral, all five of these things must be true. One, a mineral has to be formed by natural processes. Two, a mineral must never have been alive. So something like coal would not count. A mineral must have a definite volume and shape. It must be a solid. It must have unique chemical makeup that does not change over time. And finally, a mineral must have an arranged pattern called a crystal. Some things that you might think of as minerals that are not are coal, because coal used to be alive. Amber used to be part of a tree. Plastic is made by humans, so it's not formed by a natural process. Water, at least ice, is a mineral, but liquid water is not. Now, there are many groups of minerals. There are the silicates and the non-silicates. So let's go and learn more about those. Now, silicates make up about 90 through 95% of all minerals on Earth. Not by categories, but by abundance. Like there is more silicate minerals out there by weight than there are other minerals. So the most commons are silicates, and then non-silicates are more rare. So first, let's take a look at the silicates. So the silicates, all they are is they contain oxygen and silicon. They're the most abundant groups of minerals. There's a lot of silicates out there. And there's also just a lot of quartz out there as well. So you can see quartz right there on the right. Here's quartz as well in a geode. Here's another geode. Here's an entire rock made out of quartz. There's a lot of quartz out there. And there's a lot of other minerals as well. So if you look at a granite countertop or something, granite countertops contain quartz, they contain mica, and they contain feldspar. So basically anything made out of granite is all silicates for the most part. And there's a lot of granite here on Earth, guys. Even non-granite rocks like this lava rock right here, that probably contains a lot of quartz, feldspars, and micas as well. So even things that aren't, you wouldn't normally think of them as having minerals like lava rocks also contain minerals for the most part. And those minerals are mostly silicates. There's just so many of them. Now, silicates are pretty boring because there is a whole bunch of silicates out there on Earth. So when we talk about the other categories, keep in mind, there aren't that many of these, and because they're rare, they tend to be more valuable. So let's take a look at the first non-silicates. So you can see all of these things on your screen are pretty valuable, like diamonds are pretty valuable, rubies, gold, silver, copper, and iron. And here's the reason is they only make up 5% of the Earth's crust. If the entire Earth's crust was studded with billions and billions of tons of diamonds, they wouldn't be worth anything. It's because they're mostly rare that they're worth money. Rubies are actually more rare than diamonds, believe it or not. So they're valuable mainly because they're rare. Let's take a look at the non-silicates. So we're going to break that category down into multiple other categories. So the first other category is carbonates. Carbonates contain calcite. So here is some calcite right here. So here's some calcite, there's some calcite, there's some calcite on your screen as well. And basically for the carbonates, they contain carbon and oxygen. Sometimes they have other elements like calcium. For calcium carbonate or something like that. That's a real thing as well. Now, what do we use carbonates for in everyday life? Tums, they're antacids, chalk, laundry soap, concrete, neat light tricks. So calcite can actually bend light in an interesting way, diffraction. The next category we're going to look at after carbonates is oxides. Now, the oxides are where a lot of metals on Earth come from. There's the oxides, there's also the sulfides. So it's not every single one of them, but a lot of our metals on Earth come from oxides. Iron would be a good one. So paper clips made out of iron. That iron mainly came from hematite, which is pictured right here. Some iron also comes from magnetite, which is pictured here as well. So Iron comes from that. Copper can come from the oxides, like macrolite. Also, I think I have another oxide up here. No, actually I don't. Okay, so oxides, think of them as metals. Sulfides, pretty much also metals as well. It's usually sulfur with a metal. So a good example I have is galena with lead with metal, PBS. So lead and sulfur. I also have chalcopyrite right here. You can see the nice gold color. Chalcopyrite is copper, sulfur, and a few other metals. I also have regular pyrite here and here. Pyrite is iron and sulfur. So actually you can get iron from pyrite as well, also known as fool's gold. So you can see on the screen right here is pyrite. Here's galena on the screen. Here's more galena as well. So lots of different metals can also come from sulfides. So oxide sulfides are our main sources of metals as well. And here's another sulfide you wouldn't normally think as a sulfide, gypsum. Gypsum actually contains sulfur, and it doesn't really look like a metal, but it is in there. It's calcium and sulfur. So calcium technically is a metal, believe it or not. Next category is more sulfides. So we've got lithium sulfate, we've got barite. So if you're wondering where lithium ion batteries, where the lithium come from, right here, lithium sulfate. Elements, just a single element, that's it, nothing bonded to it. And for the most part, it's just diamonds, gold, and silver. Graphite could probably also be included in there, but graphite is just carbon. And so diamonds, graphite, basically the same thing, just a different arrangement. Now, last thing, how do minerals form? Two ways. Minerals can form either from cooling of magma, and for the most part, most minerals are made by magma or lava, to be honest. The second way that minerals can form is usually evaporation of water. Now, there could be other liquids out there that can sustain minerals in their solution, but naturally forming, probably not. It's usually just water is usually the only liquid out there. So let's focus on cooling of magma first. Fast cooling means you get no crystals at all. That's obsidian. And that's not a mineral. If it doesn't have crystals, it's not a mineral. So let's say you have some lava that falls right into the ocean or something like that, or it falls onto a bank of ice or a glacier. That's going to form obsidian. That will not make a mineral. If you have lava that just goes onto the surface and just cools down, within a couple of hours or something like that, that's medium cooling. Now, you might not think of lava rocks as having crystals, but they do. The thing is, you can't see them with your eyes. They're microscopic crystals. So lava rocks do have very, very, very small crystals, and those small crystals would be considered minerals. So there are minerals inside lava rocks. They're small, but they're there. Now, to get large crystals, something like quartz or, this geode right here, to get large crystals like this, it's going to take days or even months. So this halide crystal right here, you can see in my hand right here, this crystal right here, it took about 3 weeks to become that size. Crystals grow really, really slowly. And for magma, to get slow cooling, the only way you're going to do that is if you have the crystal very, very far underground. And when it's very far underground, it's insulated from the surface. It allows the crystal time to grow. Now, for evaporation, you can have it in other ways, but for magma crystals, yeah, it's going to take a long time, and it's got to be very, very far underground.